Very good evening, friends. In this video, we're discussing about the Python and the physics. This is our second video in this series, and we are trying to explain the more intricate part of the physical world, that the objects on the ground, Earth, are held by the Earth's gravitational pull, and there is something called acceleration due to gravity, represented by a small letter g, and that is called the acceleration due to gravity. Suppose if an object of mass m is lying on the ground, then it is held by the Earth's gravitational pull, and that is with a force, and that is mg, and g is the acceleration due to gravity. So if in anything like the surrounding of the earth, atmosphere, or any object on the earth is held by earth's gravitational pull, and which is always directed towards center of the earth. So if an object is raised from the ground to a height h, then we need to do some work, and that work is stored in the object in the form of energy, and we know that work is called as the dot product of force and displacement. We can also say w equal to fd cos theta. In this case, if you just look at the diagram, then the blue ball which is on the top, and the gravity is the down, so the angle between them is 180 degree, and cos 180 degree is -1. So it means the work here in this case is minus w, and that is mgh. Since work is a scalar quantity, so we are not paying much attention to its direction, we are just paying attention to its energy. Law of conservation of energy says that in a mechanical system, mechanical energy, that is called as the kinetic energy and potential energy, the sum of the energy at any point is always same. Now this is the equation of kinematics, which you know, because when the object is falling freely from the top, then its initial velocity u is 0, and the final velocity can be found using the second, third equations of the Newton's equations, called equations of kinematics. V square is 2gh and v is under root 2gh, because so some parameters are there like which we can measure, because the physical world is that world which is based on the measurements and the quantity which we can measure, just like the mass of an object we can measure, the height of an object we can measure, the time taken by an object to fall, that also we can measure. So this height is given as half gt square, and you all know that the acceleration due to gravity at place is on the earth is roughly 9.8, which is kind of constant, but it's not exactly constant, it's a variable quantity. So we can find the h, we can take h as a parameter, because the from height and the acceleration due to gravity, if the experiment is performed on earth or on the moon or on the Mars or on the Jupiter, then the acceleration due to gravity varies. So the parameters we are taking into consideration are m, h, and g. Now let's do the coding part. So I'm importing a functions called the import math, because I'll be using the math.h. So here I just create a class, and its name it will be energy. So this is class energy, and this class have I'm just initializing the variables of this class. This is called the def underscore. This is the Python part. Python is just helping us to have the more idea about the computations or the magnitude or the calculations. So it has three important parameters, mhg or mgh. So m related to mass, and h is the height, and g is the acceleration due to gravity. So I'm initializing this variable as self.m is m, self.g as g. I'm taking g as a variable because I can take the same experiment being performed on same different planets, you can say, where the value of small g will be different. So self dot g is g. So means, and m is the mass of an object, and the quantity, you know, the mass of the object does not change from planet to planet, always remains same. So now the next part is, first we'll do what is the work done in order to take the object of the mass m from the surface of that planet to a height h against its gravitational pull, and we know it's mgh. So it's returning self.m into self.g.self.h. So this is mgh, means when the object is on the ground of that planet, it has neither potential energy nor the kinetic energy. It means its total energy at that particular moment is zero. When it is raised to height h, it has got certain energy, because the work done on it increases the energy of it. So now next part is velocity, and the parameter will be passing as, I think, height will be appropriate. Is what will be the velocity, because when the velocity, when the object falls, initially the object is at rest, and after that it will be accelerated towards the planet, and that will be depending on its acceleration due to gravity. Suppose for example, if you are considering the situation of the object free fall on earth, then the height simply is already known because you are just letting it free fall from certain height. So here that's why I'm putting the height as h. Now the object starts from m, from rest, so u is 0, and at 1 second the acceleration due to gravity is 9.8. For sake of simplification we are taking g here is 10. So it means that every second the object's velocity will change from 0 to 10 in first second, then after 1 second it will become the 10 to 20, then 20 to 30, because it's accelerated towards the earth by a value g. So same thing is happening if it is this, the same experiment is repeated at different planets. So according to, like, suppose the gravity of the Jupiter is roughly 23.9, something is around 24. So in this condition we are just trying to find out the velocity of the object at a height from the top, that is called the mh. Means what is the velocity at a height, or you can say at a depth from the top, means what the velocity it has acquired, because we know that it's starting from the zero velocity, right? So just continue. So this is the velocity, and that is returning math.sqr to 2 into self dot g into mh, that is under root 2gh. Now the kinetic energy, you know that kinetic energy is half into mass into velocity square, half mv square. So I'll write in the code, it's called half mv square. And the velocity function we are getting from the velocity function, so it will be just like 0.5 self into velocity. Just look at the code, we are using the formula half mv square. So this is half mv square. Okay, so this is the programming part, because we are trying to find the better results. So this is the velocity. So after some times it will acquire the velocity till it touches the planet. So now the potential energy at that very same moment will be mgh, but it will be mg the total height minus height from the top, because at middle point say mgh. So we are passing the value h because it is the height from the top where we are trying to find out the potential energy, because when the body in the system of equilibrium of energy, you know that's when the potential energy is decreasing and the kinetic energy is increasing at the expense of the potential energy. So at a certain height the kinetic energy proportionality increases and the potential energy decreases. So now let me just work on this part where I'll be expecting certain values from the user. This is now purely Python part. So m equal to enter the mass of the body, and that value will go into m, and then enter the acceleration due to gravity, because it's depending on the planet where you want that particular experiment to be performed, on Earth, on Mars, or whatever. You can go on the Wikipedia, you can find the value of the acceleration due to gravity of that, because gravity is the intrinsic property of the bodies having mass, and every body, every planet have its own gravity, which can be different, but it's kind of the basic laws governing the physics are roughly same. So enter the maximum height of the body, and then we are letting the user enter that at what height from the top the value needs to be calculated. So this is enter the height from the top. This is what I'm saying. Yes, so I have written the enter the height in between, but I'm just again saying that it is the height entered or calculated from the top, not from the bottom. So now I'm creating the object of this energy and the passing this mgh to it, and then I will be calling these various functions work done, kinetic energy one by one. So this is printing the work done or the maximum PE, the maximum work done by the person to take the object to that height h, and it is work underscore done function is doing the calculation part. So I'll pass it into the string streng dot work underscore done. Now let me copy paste. Now this part we are trying to find out the velocity acquired by the body after free fall, because after falling to a certain depth or to the height, means because when it is falling definitely it is covering, but here in this condition we are measuring the height from the top. So we have to pass the height what we have measured. So mh we are passing to the velocity, and then we have to make corrections because perhaps it has to be there also. Kinetic energy part is fine. When you start writing the code, then you find there are several ways by which same thing can be done. So you just slowly get confused which is the better option, which is the better way of doing this. But there are always many ways by which a particular thing can be done. Let me make certain changes to the statement so that you can understand exactly what we are trying to print out. So the kinetic energy, because eng.ke this series we the thought came to our mind because we wanted to remove the fear from the mind of those who study physics, because computation part everyone finds little difficult. Remembering the definitions is easy, doing calculation is little tricky, and asking different these days. I have found that the students find it very difficult to adjust to the situations when they are asked different kind of questions from different angles. Flexibility, like you can say, the mind should be like elastic so that it can think on everything and without losing its cool, but these days it's not happening. Now let's see certain things we have written. Let's see how the results are coming. So 20, this is the mass on objects in the SI system, 20 kg you can say. Acceleration due to gravity is 10, this is roughly 9.8, and the maximum height of the body is 200, this is the maximum height. And then enter the height in between where you want to calculate from the top. So here I'm just 200 becomes 0. So it has got certain errors, and the errors are that we kinetic energy we must be passing the mh, because kinetic energy self dot velocity dot this is okay, no problem. So we'll make certain calculations. Kinetic energy, this when kinetic energy is calculated, then the velocity function needs to be passed certain values. So because yes, here then I'll write mh, yes, here also right, because at what height, because the velocity keeps on changing from the top till the bottom just before touching the ground, because just its velocity is maximum just before touching the ground and the minimum when it starts journey, because it starts from 0 at rest. So here I have to pass these two values. So kinetic energy means this is mh, means the height what the user. Let's see what do we get here. So 20, 100, this time 200, and the height in between I write just 50 meters from the top. So two values are coming, potential energy is coming, and here it says that the argument mh work done also. One little problem, syntactical errors. So yes, here work done is not receiving any function from the user. It is working on mgh, the value initialized in the class. So let me do again. So 20, 100. Okay, so let me make certain corrections here. Because height is potential energy at intermediate position should be this one means the total height minus height from the top, and let me rename it PEA. It means potential energy at that height, kinetic energy at that height, because at each and every height that it keeps on changing. Now I hope, let me change changes in the call also. KEH at that particular height, because from the top to bottom kinetic energy increases and the potential energy decreases. So at each and every moment the total energy remains same, but the kinetic energy is getting it's increasing, but at the cost of the potential energy. And this is the idea of the law of conservation of energy. So total energy at that point, at that height, will be the sum of the kinetic energy and potential energy. Now let's run the code and see, perform the calculations what we are entering here, because for different inputs the different calculation needs to be done. I have computed, and that's why I'm saying that it's providing the better answers. And the height is 2000, so it means the potential energy will be 2000 into 100, 200,000. Now you see it's coming clear, and the total energy at point is also 200,000, so this is always at the 200,000. The potential energy in the middle point is something like a little lesser, and the kinetic energy is also velocity required. So all these values are giving correct values. Thank you very much, keep on watching, and please add some comments to it so that we can understand what it is, because this is totally the new way we are starting physics and mathematics, and it is only for those who study physics and those who enjoy Python. So these parts I'm just making certain changes just only to enhance the look and feel, to increase the equal sign so that height equals to, this way you can find this result will be better. And because it is just printing this, but the theme is that calculation is done by Python, and idea of the physics is explained by me. Thank you very much. Just subscribe to our channel. Have very nice time.